Okay, so before we move on, there's a bit of an issue because the Latin alphabet that we all know, A, B, C, D, has 52 symbols, 26 lowercase, 26 uppercase. The Greek alphabet, lowercase and uppercase, add 33 more. Cyrillic, from Russian and whatnot, adds, well, altogether it's 98 symbols. So how do we handle more than 98 variables if we only have 98 symbols? And you might think, well, I never want to work with 98 variables or more, but real-world models will have something on the order of 500 variables or more. A simple model of the economy would have 451 sectors. Each of them would have at least one variable. So we need to be able to handle this. And the solution is to use index notation. So we add subscripts. That's the trick. We just write x subscript 1, x subscript 2, x subscript 3, and so on, all the way to x subscript 451. And there you go. 451 new symbols. Just using one symbol and numerals to distinguish the different variables among themselves. And each of them could have a coefficient, A1, A2, all the way up to A451. Now, the subscripts do not have any magical powers. It is not, I repeat, not like exponentiation or some similar mathematical operation. It's just syntactic clarification. It's just what we do to write down different symbols, recycling one symbol. Now the subscript is called an index, and it's not uncommon to have an index variable. So you might see something like x subscript I, a subscript j, and so on. We have to be careful whether we're summing over the subscript or not, but these just refer to a family of symbols indexed by I or j, and we treat them as if they were completely separate objects. So it is not at all a exponentiation, and I will make sure that in this course on elementary linear algebra, only subscripts are used, and it will only mean one thing. Simply that we're dealing with an indexed object, a family of variables or a family of parameters of some kind. So that is it for index notation.